Alright, let's do some simple example problems from section 5.5 non-inverting amplifier. So here is a very simple example, very straightforward example. As a matter of fact, we have a non-inverting amplifier. How do I know it's a non-inverting amplifier? Because the input is applied to the non-inverting terminal. Okay, the input is applied to the non-inverting terminal, hence we have a non-inverting amplifier. Also notice that there is a negative feedback configuration. Okay, now there are a couple of ways to do this problem. You could well, first of all, what are we supposed to find in this problem? Output voltage. Okay, output voltage, all the values for the resistors and the voltage source is are given. Okay, so solution. This is going to be a really quick problem actually. If you think about it, we are interested in writing step 1. Step number 1 is to make sure that there is a negative feedback configuration. We already did that. Now, so the step 1 is writing KCL at node Vn. Okay, that guy is Vn. Okay, but sometimes, as you have seen in the previous problems, I like to do step 2 first. Okay, or the step 3 first. Okay, what does step 3 say? Step 3 simply says Vp equals to Vn. Okay, Vp equals to Vn, where this guy is Vp. Okay, that is the application of a voltage constraint. Okay, rule 1. We have done this so many different times. Okay, so that's given to be 2 volts. Vp is given to be 2 volts. Okay, also Ip is In is 0. Okay, that is the application of the current constraint or rule 2. Now we are ready to write KCL at node Vn, right? At node Vn, the current going in this branch plus the current going in this branch plus the current going in here, which is really 0. Okay, all those three add up. Okay, because this is the same branch coming out of the node Vn here. So the voltage here would be Vn minus ground, which is this guy is connected to ground, right, by 25 kilo. And the current in this branch happens to be, this guy is connected to Vn, and this voltage is connected to V0 by 150k. Okay, and then the current in this little branch is 0. So let's add both of those. Vn is given to be 2, which is given to be Vp. Okay, Vp is given to be 2. Vn minus 0, that guy is 2 divided by 25 kilo, plus this guy is 2 minus Vo, 2 minus Vo divided by 150k. Okay, all of that equals to 0. How did I get this? Because Vn minus Vo over 150 kilo ohms. Okay, I know Vn is 2. Okay, all right, now let's simplify this equation. 2 by 25k plus 2 by 150k equals to V naught over 150k. Okay, multiply both sides of the equation by 150k. I have 2 into 150k divided by 25k plus 2 equals to VO. Okay, so whatever that comes out to be, so this multiplies 6 times, so V naught equals to 14 volts. That's it. Pretty straightforward, simple problem. As you will see, we are going to look at some more interesting, one more interesting example of operational amplifier in its non-inverting configuration. See you in the next example problem.